Now, area between two curves. That's probably what this section starts off with. Area between two curves is, like I said, fairly simple because all you do different is you subtract g of x. They'll give you some kind of rule like the antiderivative from a to b of g of x minus f of x dx. Where you have, let's just start off with something simple. Let's say you have this function and you have this function right here. Well, let me go back and change one of them to red. Like that. Now, of course, if you want to find out where they intersect, what do you do? Set them equal to each other. So, to find this point, set equal to each other. And once you get that point, you have your A to B, because most of your curves in this section will be starting from what? 0. They're a little bit nice to you. And then what you're going to do, the antiderivative is basically going to take your this method pretty much, not this or wash it, but basically do your hatching. Okay. And that's the area of the curve, or area between two curves. So let's try one. Let me find one that's a decent one to start off with. How about negative x squared plus 2x and x squared? Negative x squared plus 2x and x squared. Try that. And draw it first. I want you to draw it. Or you don't have to draw it perfectly, just draw a sketch of it. F of x is equal to, what I say, negative, or negative x squared. What did I say? Plus 2x. And then g of x, I'll make it blue, is equal to x squared. So the first thing you do is you sketch it. Now most of the time they will have it sketched for you, but if they don't, you need to draw a sketch so you at least know what's going on. Negative x squared plus 2x, just complete the square. Negative x squared plus 2x plus blank is equal to 0 plus blank. And and factor out the negative, that'll give you x squared minus 2x plus blank is equal to 0 plus negative, whatever that is. Half of 2 is 1, right? And 1 squared is 1, so that'll give you negative x minus 1 quantity squared is equal to negative 1. So our vertex is negative 1, positive 1 and positive 1. So there's that. And divided by negative divided by -1, you get x minus 1 quantity squared is equal to 1. Take the square root, x minus 1 is equal to 1. Sorry. Is equal to 1. And add 1x is equal to square root of -1, positive -1, positive -1 plus 1. And that will give you 2 and 0. So we've got a vertex at 2, 1, 2. I mean, not a vertex, x intercept and it's 0. So, everybody good with that? And the other one, the blue one, is pretty simple because you have x squared, 0, 0, 1, 1, 1, 1, 2, 4, 2, 4, and it looks something like this. Now, of course, you see that it's crossing right here, and this is where we're going to focus on. I can't express to you how much drawing a picture helps. Now, in Calc 3, that's all you're going to be doing is drawing pictures. How many of you have had physics, 1 or 2? What are you doing there? Free body, all you do. And in Calc 3, that's all you're going to do. And in this, you're not going to do it as much as you do in Calc 3, but in this class, you're going to do a lot of drawing because you have to. You've got to see it before you can do it. And that's true with any problem, whether it be financial or whether it be structural or mechanical or whatever the case may be. In order to understand the problem, you got to see it, right? Yes, you. Thank you for that. So, where does it intersect? Well, set it equal to each other. Negative x squared plus 2x, okay, is equal to x squared. And bring that x squared over, what happens? What do you get? 2x squared to 2x is equal to 2x squared. And I'm just going to bring that negative 2x over here. And then we can factor out 0 is equal to 2x. And that leaves you with what? X minus 1. So 2x is equal to 0. And x minus 1 is equal to 0. X is equal to 0. So it intersects at 0 and at what? 1. Now, the reason I'm doing these steps is this is the way you should be doing it no matter what. Because not always you're going to be able to see where the intersection is. You're going to have to calculate. Now, at this point, you're thinking two things. You're thinking, what does it look like? And where does it intersect? And it intersects at 1. Now, you just need to discern which one is the higher value. Now, or the upper value. Now, it really doesn't matter because you're going to end up with the same answer. But you're going to come out with a negative area if you pick the, not wrong one, but the lower one first. So, this one looks like it's going to be, for this area right here, pick a point. Pick 0.5. Well, 0.5 quantity squared is going to be 0.025, so it's going to be right in here. And 0.5 quantity squared with the upper value is going to be up here, so this is your upper value, so this is going to be f of x. And you're going to subtract g of x. Now, that's when they don't give you the upper area or the lower area. In this case, they pretty much did, so we're going to go from 0 to 1 of f of x. What was f of x? Negative x squared No, that's g of x. No, that's right. F of x is negative x squared what? Minus 2x. And then we're going to subtract x squared dx. Alright? You always got that dx. Because what is dx? That's the width of your strip. This is your width of your strip. And what is this? Or this is your base. What is this? What's the height? Alright, so negative x squared minus x squared is what? Negative 2x squared. Thank you for the interaction. Minus 2x dx. What did I?
The original equation was negative.
Okay, I didn't. I thought it was mine. That better. Just trying to change the problem in the middle of the problem. That's all. All right, finish it out. Yeah, just come on in whenever you want to. That's fine. Should have brought everybody biscuits.
One time to get my coffee from Starbucks, and then I had to go all the way to Sam's Club to get my bag of energy drink. So it was.
It's my fault, isn't it?
It was Bush's fault.
Okay. Well, I thought it was my fault because I told you to get coffee and. Okay. First of all, you go to Starbucks. I cannot walk in. I walked into Starbucks one time, and I said I never will again. It's too liberal for me. Too many hippies in there.
It used to be real funny. I used to go to the old restaurant I worked at. They'd always send me to get Starbucks. And my car was, the car I used to have was just a straight flat 4-cylinder. And so I'd be going through the drive-thru and I'd cut off my car and be sitting there and I'd order everything.
Yeah.
And I'd crank it back up and I'd pull up to the drive-thru and they couldn't, and nobody could hear anything. So it was just
Why did you have straight pipes out of a 4-cylinder?
well, I was dropping my transmission to replace my rear main seal on the motor, and the exhaust system was rusted out behind the cap, and so whenever I was trying to unbolt the exhaust system, it fell out.
out.
The cap, and I was like, well, I'll put it back on there later, but I started it up just for shit to do,
Yeah.
figure out what it sounded like, and it sounded like when it idled, it sounded like a little tractor.
Yeah.
And I was like, I love that. I just left it, just a little 3-foot down pipe, and now in higher RPMs, it made you want to kill yourself.
At least you didn't run a pipe through the bed. At least you didn't run a smokestack. So. Yeah, rear main seal's bad on Fords. Fords, I don't know what'd you have.
That was a Suzuki Samurai.
Oh. Rear main seals on Fords are real bad about going out, especially the old gas burners, the 351s.
Yeah.
They go out real easy. All right, so integration. So we're going to set up integration. That's going to be x squared to be x to the third over 3, and then x to the second over 2, right? So let me just copy this over. Keep hitting the wrong button. So copy this over. Okay, copy the whole thing. Whatever.
subdivision.
I give up. All right. So that's going to be -2, and then you got x cubed over 3 plus 2 x squared over 2. And that's going to be evaluated at 0 and 1. And that's going to be -2/3 x cubed plus x squared, evaluated at 0 and 1. I'm going to do 0 for y'all. 0 to get 0. Y'all do the other one. And that's going to be -2/3 times 1 plus 1. And that's going to be -2/3 plus what? 3/3, which is what? 1/4. And that's your area at 0 and 1. Of course, you're not worried about the units of measurement, because the units of measurements coincide with whatever your lengths and heights are, whatever the case may be. Question on that one? Now, some of y'all have had exposure to areas under curves, area between curves. Yes or no? Yes? Okay, so this is just second. This is kind of a review again, okay? I don't know what they've, when they got this new book, the review had changed. So evidently they're reviewing a little bit more on some of the Calc 1 concepts. So this is the first time I've taught out of this book. All right, let's try another example. Let's try this one. Y is equal to x over the square root of x plus 1, and y is equal to x to the 4th minus x. I'll write it on the board so you can see it. Y is equal to x over square root of x plus 1, and y is equal to x to the 4th minus x. Now this is where your graphic calculator comes in handy, because you don't want to spend a lot of time graphing this. I mean, because it's going to be time consuming. So what I would do is use your graphic calculator. If you don't have one, you can go to Wabbit, W-A-B-B-I-T-E-M-U, Wabbit EMU on your cell phone, and you can download it. Download the PI. I don't know about your iPhone people, because iPhones are so different. I know that the Wabbit EMU is for Android. All right. Huh? What? What did I say? Oh, well, I didn't want to. Well, that's what I... All right. So let's go ahead and do this. I'll change it to a white screen. And okay, whatever. Go back and do the other one. Right on top of it. All right, so graph those two. Take your handy dandy calculator. And our first one is y is equal to x, and I'm going to put parentheses around it, x divided by parentheses square root of x plus 1 close parentheses, close parentheses. And your next one is x to the 4th minus x. And I'm going to change them a little bit. I'll make this one darker. And let's see what it looks like. There's the first one. And there's the second one. So let's take and zoom box. You know I'm a CAD person because I know how to zoom window. I'm the only person I think that ever does this. I'm used to zooming with a window. And zoom box. Sorry. And that's what it looks like. Alright, so now you transfer that over to a sketch to where at least you know what it looks like. And it doesn't let you. It looks something like that, and then something like this. Okay. Okay. Do both at the same time, something like that. Okay, crosses at 0, so I need to change mine to 0. Something like that, I don't know. When the technology don't work well with you, you have to make adjustments. So. Okay, that's close enough for government work. Alright, so set them equal to each other. X over the square root of x plus 1 is equal to x to the 4th minus x. Multiply both sides by the square root of x plus 1 because I got to get it out of the x plus 1. Square root of x plus 1, that's going out, so you get x is equal to the square root of x plus 1 times x to the 4th minus x. I don't know if we're going to be able to solve this. We may just have to do a trace intersection. Makes it be a whole lot easier. Distribute this. We get x is equal to the square root x to the 4th square root of x plus 1 minus x square root of x plus 1, and there's just too many x's to solve this, so I would suggest doing a compute intersection here. It looks like to me it's 0 there, but it's going to be a mess. Looks like to me you can almost use substitution right here and factor, but I think that's going to mess up right there because that's going to come over. And that's going to be x minus x to the 4th square root of x plus 1 plus x times square root of x plus 1 is equal to 0. Factor out of x. And that's going to leave you with 1 minus x to the 3rd square root of x plus 1 plus square root of x plus 1 is equal to 0. So at least we got one intersection. X is equal to 0. So there's that one. And I'm just going to set this up, negative x cubed square root of x plus 1 plus square root of x plus 1 plus 1 is equal to 0. Yeah. I would just go ahead and do a calculation, and that's where technology comes in, because that's going to be a mess to solve that. So pull up your handy dandy calculator and do second function, calculate, dang old intersect. And again, I don't know what y'all know and what y'all don't know, so just second curve, yes. And my guess is going to be right in here. And do y'all get 1.18 or 1.19? Is that what y'all got? Yeah. All right, so write that down. That's your intersection point. That's your B. So 1.19, 0 to 1.19. And of course, your upper value is going to be this function. Well, which one is that one? Well, that's going to be your, wasn't that this one? I think it was. Can't remember which, I think it was this one. Yeah. So it's going to be this one minus that one. So I'm just going to erase this portion over here. Somebody confirm that for me. Make sure. Isn't that one the one that looks like the natural log? So we've got the absolute, I think the absolute value, from 0 to 1.19 of x over square root of x plus 1 minus x to the fourth minus x over 1. And the reason I do that is you've got to get a what? What if you got to get it to two fractions? Common denominator. Go ahead and work on that. Good old algebra. Now you know why you take 2 or 3 algebras before you go into calculus. Now you could, instead of doing the algebra, you could just go ahead and take the antiderivative. You could do that. Because that first one, can't you take the antiderivative of x over x plus 1 if you use x plus 1 as u is equal to x plus 1? I don't know. It may not. I don't know. It could help. Or is that supposed to be x squared plus 1? It's supposed to be x squared plus 1, is it not? I think it is. Did I write x or x squared? It's supposed to be x squared. I don't know why I keep doing that. Maybe that's it. Should be x squared right here. Y'all check me. It's in the book. Huh? Yeah, it does. Changes it. Huh? Yeah, it would be UDU, but I don't know why I didn't. What did I put in the calculator? Yeah. How much would it change it? Well, no, it didn't, because the intersection point is still the same. Couldn't change it that much. Oh, great. Second insert, second, x squared plus 1. Is it plus 1? I think 1.18 is still the intersection point. Check it. Let's see, second function, calculate, intersect. Dang old first one, dang old second one, dang old yes. Okay, well, we're off by 100, okay? Okay, 1.18. So, my bad. Of course, I didn't do that. It's all Bush's fault. $1.18. All right, so go to 0 to 1.18. I believe you don't have to use the algebra. I believe you can just do the antiderivative of each. It might be easier to do that. You could get a common denominator. I mean, it doesn't matter to me. X minus x would be x plus x. You're going to get x to the 4th. Yeah, it'd be a whole lot easier to do that, not to do the algebra. Because this, what is, yeah, that would be 2x dx, so you'd put a 1/2 out front, right? So that would be 1/2 the antiderivative of 0 to 1.19, or 8, sorry. Let me just rewrite it. That's going to be 2x dx over the square root of x squared plus 1 minus from 0 to 1.18 of x to the 4th minus x dx. You get the point. So what do we have here? We have du over what? U. This is u to the 1/2. So we can just bring this up and make it u to the negative 1/2 du, right? 1/2 0 to 1.18 of u to the negative 1/2 2x or du, sorry. Now, since we're changing that to u, we've got to change that 1.18, correct? Yes, Hubert. Thank you, class. Huh? X to the 4th dx minus absolute, antiderivative 0 to 1.18 of x dx. And change that 1.18, what does it change into?
You go back and plug X.
I'm sorry, what?
You go back and plug X.
You don't have to. You could just leave the 1.18 if you change it back. Yes, you can do that. That's fine. It depends on what you want to do. But if you change it, it gets to be what, 3? Close to 3? Okay. I think it's close to 3, 2.9 something. Somebody crank it through and see. What?
Why do you change the interval when
because you're changing, you're substituting. You're substituting something in for for x plus 1. So you can't change the form of the problem and not change what it puts out. That's why. So you would plug in 1.18 and divide it by the square root of 1.18 plus 1. Somebody crank that out and you should get 2.99.
I got it. 1.68.
It comes out to be 2.99. All right, finish it out. Let me pull that up for you while y'all are doing it. Let's see if I can find it. Where is it? It should be under substitution. What chapter was substitution? View substitution. Was that the last one we went through? Let me find it. Integrals. Substitution rule. Page in your book, you got your book with you? 411, example 7. I think that will help you out. So what is, plug the 1.18 into the x squared plus 1, because that's what u is equal to. What do you get? 1.18 into x squared plus 1. Okay, I'll do it. Y'all are concentrating. 1.18 raised to the second power plus 1. Okay, 2.39. I was off. 2.39. So that's your new value, 2.39. So you go back to your and change this right here to 2.39. Sorry, 2.39. 2.39. All right, now all it is integration. So let's take this guy. Really? And that's going to give us 1/2 u to the what? U to the 1/2 over what? 1/2. Evaluate it at, and we'll just evaluate the whole thing, minus be x to the fifth over what? Over 5. And that's evaluated at 0 and 1.18. And minus x squared over 2 evaluated at 0 and 1.18. And this is evaluated at 0 and 2.39. But if you change this back to x, if you change it in respect to x, what can you change this back to? 1.18. So I don't care how you do it. It don't matter to me. All right, what happens to the 1/2? They cancel. So you're left with u to the 1/2 evaluated at 0 and 2.39 minus x to the fifth over 5 minus x squared over 2 evaluated at 0 and 1.18. Or you can change this back to change it back in respect to x, which would be what? The square root of x squared plus 1. You could change that back if you wanted to and use the 1.18, whichever one you want. Which one did they do in the book? I got the book in front of them. I'll pull it up. Hold on. What page? Oh, I done changed pages. Let me just go back to 6. Sorry about that. And is it right here? Yeah. They used u. So square root of 2.39. So square root of 2.39 minus all this stuff. So let's take this to the next page. Again, what do you notice? You notice, write every step down. Because you know what's aggravating? It's trying to find errors when you skip steps. That's very aggravating. Of course, y'all don't make mistakes, do you? Huh? I taught calculus classes that there were actually people in the class that thought they were perfect. Oh, you did? Where'd you go to high school? and I ain't gonna say nothing. My mom is from Belton, so I ain't gonna say nothing. All right. So square root of 2.39 minus, and of course 0. Thank God it's zeros here. We'd have a mess. Minus 1.18 to the 5th power over 5 minus 1.18 squared over 2. And what's square root? What's 2.39 square root? Well, I'm gonna let y'all do that because you got the answer in the book to check. Let's see what they got.
So this is going to be needed in terms of the even substitution. Just done all of them now. That's
Mhm.
what we've done before.
Yeah.
That's what we changed it.
Mm-hmm.
Okay.
There you go. 0.785 is what you should get. Question on that one? All right, let's look at some. Let's look at some others. All right, let's try this one. using the sine and the cosine. X is equal to 0 and x is equal to pi over 2. Try that one. I'll blow it up for you just so you can see the problem. But I want you to work it. I don't want you to just look at the answer. I want you to work it. Well, there it is set up basically. You have to pay for that electricity.
Yeah. I'll ship it.
Oh, okay. Is that included? Is that the service fee or the lab fee? All right, so subtract it out. Now, let me ask you a question. Some of you may have done this in Calc 1. When you have symmetry, what do you have to remember to do when you have symmetry? Multiply it by 2 or add the 2 together, right? Don't forget that. You've got symmetry here. When you're doing cosine minus sine, you're just doing one area. So you got to add them together. So don't forget that. And you have to make adjustments with your values or multiply it by 2, whichever one you want to do. But if I was you with this one, since it's like a bow tie, I would go from 0 to pi over 4, and then from pi over 4 to what? Pi over 2. Or you could multiply it by 2, either one. Go ahead and call the roll while thinking about it. Everybody here today? Not here, raise your hand. Of course, Mr. Fowler is not here. Oh, Mr. Fowler. All right, let's see. How many we got here today? 3, 4, 5, 6, 7. Well, we got more than 7, so I got to call the roll. Alexander.
Yes.
Okay. Bowling. Corwin. Mealer. No Mealer. Oslin. Robinson. Urban. Vaughn. No Vaughn. Williams. No Williams. And Wiseman. Now, in this case, it's not gonna matter which one is cosine and which, I mean, you're going from one to the other, so you could actually go cosine minus the sine plus the sine minus the what? You could do it that way. If you want to. I mean, it's not that big of a deal. So, I gotta bring this down so I can draw on the board. What's that noise? It stopped working. Do y'all see the cursor? What? I know that, but when in doubt, unplug it. Really, don't do this to me. It hadn't done this since 2 semesters ago. That's why they had to change these cords. This purple cord costs like $200. It's a special cord that goes to that board because the boards are so old. They had to use the old parallel port, and they had to convert. This is a long story, but the boards are old. And see, if that board goes off, I lose everything I've done on this screen capture, and that messes me up. It looks like the recording has stopped anyway, doesn't it? No, it hasn't. It's going. All right, I'll just have to finish on the... Shoot. I'm sorry. All right, so here we go. I know it does, but in this case, it usually, I'll just try it in a minute. All right, y'all give me my, since I can't pull up the book and draw on the board, what's the values on the left-hand side? Huh? What's my A and B on the left-hand side? Okay, I'll just do it. If y'all don't want to talk to me. 0 to what? 0 to the power of 4, thank you. 0 to the power of 4. And that's what? Cosine minus sine? Cosine x minus sine dx. Plus, and you can either multiply it by 2, or you can go from the next one, which is what? Pi over 4 to pi over 2. And that's going to be sine minus cosine. Yeah, it's not. You piece of crap. No, if I reset it, I lose the screen capture. And I don't want to do that. Oh my. Huh. The computer's working. It's doing the orientation. But that's not. So it was on that the whole time? I thought I hit it. Well, that still on display and making, why did it make that noise? Damn bush. Now is it working? I don't know what the heck happened. Okay. Alright, so 0 to the power of 4 of cosine of x minus sine of x dx plus power of 4 power of 2 of sine of x minus cosine of x dx. Or you could set it up as 2 times 0 to the power of 4 of cosine of x minus sine of x dx. Now, why would this be easier? Two reasons it would be easier. You only have to do one side, you multiply by 2, that's one reason. What's the other reason? No? But we just said that. That's what the first reason is, yes. But why is it going to be easier to do it this way than that way? Two reasons. One, because these are the same, so you just multiply by 2, right? So that's one reason. But what's the other reason it's an advantage to do this one rather than this one? Anybody want to take a guess at it? Look at your A's and B's. 0. What do you got to do over here? You got to do more math over here. So it's better to do it this way. So whatever you want to do. Okay? So what's the antiderivative of cosine? Negative sine, isn't it? And what's the antiderivative of sine? Huh? I thought the antiderivative of cosine is negative sine. Or I get them mixed up.
Yeah, antiderivative of cosine is sine.
Okay, and the antiderivative of sine is negative cosine. But the negative cosine is going to be positive because of the what? Because of the negative. So when you do this, you're going to get 2 brackets sine of x what? Plus cosine of x evaluated at 0 and pi to 4. So 2 brackets sine of pi to 4
Priority 1 message
plus
coming in on secure channel.
cosine of pi to 4 minus sine of 0 plus cosine of 0. Now, what's pi over 4? Dang old 45 degrees? Alright. Now, let's say that you've forgotten all that stuff that you've forgotten, pi over 4. Just say 45 degrees. 1 square root of what? 2. And then just find the sine and the cosine, or whatever you need. Alright? So what's the sine of 45 degrees? Square root of 2 over what? 2. So put that in there, square root of 2 over 2. What's the cosine? Square root of 2 over 2. And then the sine of 0, well, just remember that your two things over there is going to be your sine and your cosine. That's 0 and 1, right? Or is it 1 and 0? Let's see. 1 and 0. So that's your cosine is 1 and your sine is 0. So 1 plus 0 is there. So even if you've forgotten your chart, you can still do this by just using your what? Brain. So 2 brackets, square root of 2 over 2 plus square root of 2 over 2 minus 1 plus 0 is 1. And square root of 2 over 2 plus square root of 2 over 2 is 2 over what? It would be 2 plus square root of 2 over 2, which is square root of 2, right? Square root of 2 minus 1. And square root of 2 is 1.41, so that'll leave 0.41 multiplied by 2 is 0.82. I mean, y'all do the math. What does it come out to be? I get 0.82, but I'm going to add a squiggly equals, meaning I did it in my head. What do y'all get? 0.83. That's a good test question. Hint, hint. Okay, now here's where we switch gears. What's the difference here? What are we doing here? I'm on page, for those of you that have a book, I'm on page 426. What's happening here? We've been going around the x-axis, right? What are these guys doing? Going around the y-axis. So this is where you have to put things in terms of y. Alright? So write that down. Area is equal from C to D of f of y minus g of y dy. Same concept. Just think of the x-axis as the y-axis. And it'd be the top one minus the bottom from C to D, or D to C, whichever one you want to do. The area is not going to be, it's going to be the same, negative or positive. So where would you see this? Well, they give you a problem, right? This right here. Find the area enclosed by the line y is equal to x minus 1 and the parabola y squared is equal to 2x plus 2. What have they done? They've rotated it, basically, or they're making you go around the y-axis now. Now, what we're going to do is we're going to do it both ways and see what happens. So go ahead and do it around the y-axis. So that means you're going to take y plus 1 and subtract what? You're going to subtract 2x plus 6. That's right, class. And then, what? And how can you? How do you know that? By you looking at the book? No. How do you know it? By drawing a what? A picture. And luckily, they have a picture here for you. You can see more with the picture than you can with anything. So, it's going to be y plus 1 minus what? 1/2 y minus 3 from what? Negative 2 to what? Positive 4. Alright, set it up. Dang old vertical. Dang old y-axis. let's see, I need to. This button is not working on this thing. I think it's because the battery case is gone. I mean, the back of the battery. I done hit it like three. Oh, the batteries were coming out. There we go. All right. Okay, I'm not crazy. This thing's making noises.
Priority 1 message coming in on secure channel.
Okay, people. Something is going on. All right, give me the one that goes like this. What's that one? Sorry, what? It's not x is equal y plus 1? Okay. And then give me the other one. The one that goes the other way. Huh? 1/2 y squared minus 2? 3? And from where? You gotta tell me again. -2 to what? -2 to 4. So first of all, do your algebra. So -2 to 4 of y plus 1 minus 1/2 y squared plus 4 dy. And that's just going to combine like terms. So that's going to be -2 to 4 of y minus 1/2 y squared plus what? 5? Oh, I'm sorry. I just changed this into a 4. I think I did the math in my head. There we go, 4. All right. How does that look? Now, let's take this, turn it around. And that's going to give me -2 to 4 of -1/2 y squared plus y plus 4 dy. And that's going to give me -1/2 y squared over 2. So y to the third over 3. Plus y squared over 2 plus 4y evaluated at -2 and 4. And I'm just going to take this if it'll let me, which it probably won't. This thing is not user friendly. Clipboard. I think it's having a moment. All right, that's going to give me -y to the third over. No, it's not. Yeah, -y to the third over 6, right? Plus y squared over 2 plus 4y evaluated at -2 and 4. So that's going to be parentheses cubed over 6 plus parentheses squared over 2 plus 4 times parentheses It'll be most of the time, do the same thing. I was gonna copy it and. I don't know how to do it. Oh, man. I'm trying to make things easier, but that's what I was trying to do. And we're going to plug in a 4 here and a -2 here. And 4 cubed is what? 64? So that's going to be -64 over 6 plus 16 over 2 plus 16 over 1 minus -2 cubed is what? 8, -8, and then a +8 is 8/6 plus, be a minus, sorry, minus 4 halves minus 8 over 1. Y'all check my math. I'm not worried about reducing right now because that's furthest from my mind. Because you got to get a common denominator if you're doing this by hand. And that's going to give you -64 over 6. Where? Right over here? Did I not have 4 over 2? What I have? Oh, right here? Yeah, you're right. Thank you. Okay, so that's 32, let's see, 3 times 16 is 48, plus 96. Y'all check my math, make sure I converted right. And this is going to be 8 over 6 plus 12 over 6 minus 6 times 8 is 48. -64 plus 48 is what? -16? -16 plus 96 is 80. Y'all check me. Minus 8 plus 12 is 20. 20 minus 48 is -28. Which is equal to 80 plus 28, which is equal to 108 over 6. And you can reduce that down to what? 54? Help me out. Over 3? Huh? 18? Is that what it comes out to be? 18 over what? I'm sorry, what? 18. As you can see, the math can be what? Very tedious, so be careful. Let's see what they got. 18. Alrighty. So now y'all got y'all's first section to work on. I'll put some homework problems up and it'll be called homework for 6 point what? 6.1, okay? Unless y'all want to go over another section. Oh, you don't? Okay, well, we'll call it a day. Huh?
That board is kind of funky today.
I just want to go home.
What? Oh yeah, well, at least you can sit and do nothing. How about that? Play on the computer.